Hey guys, welcome back. Today we're going to solve LeetCode number 452. So we're given a list of start and end coordinates of some intervals which represent the diameters, the horizontal diameters of some spherical balloons, and we need to return the lowest amount of arrows needed to pop all of those balloons. And keep in mind that once you shoot an arrow at a certain x coordinate, all of the balloons which are in that x coordinate are going to get popped. So this is one of those problems where sorting the input is really helpful. So since we can think the coordinates of the diameters as intervals, we're going to sort those intervals based on the end coordinate in an ascending way. So now that we've sorted the balloons array, that's going to allow us to process the balloons array in a greedy way. So before doing that, we need to set up our remaining variables, which are the arrows needed. This is the return value, essentially, how many arrows are needed to pop all the balloons. And this is one variable that is going to be very helpful. It's the amount of balloons that are popped with the current throw of the arrow. Because now we're going to have a loop, a for loop, which does one iteration for each arrow that we throw. So here we're going to set up the for loop. First of all, the current balloon that we are iterating on. Then we also need to check that the current balloon is inside the bound of the array. And now comes the tricky part. We need to skip all of the balloons that we've popped. We don't want to iterate on those. So we're going to have to update this value to hold the amount of balloons that we've popped. So this is not the usual, like if this was a conventional for loop, this would be current balloon plus plus. But instead, we need to skip all of the balloons that we have popped in the current throw of the arrow. And obviously, we also need to keep track of the fact that for every iteration, we are launching one arrow. So yeah, just increment the arrows needed counter. So here's when the greedy part comes in. Since we've sorted the balloons array, we can now solve how many balloons we've popped in a greedy way. So first of all, we need to store the end of the current balloon that we are iterating on. So yeah, that's just literally that. Access the balloons array on the current balloon index and take the end of its horizontal diameter interval. And now store initially the amount of popped balloons is 1 because we are at least popping the current balloon that we are iterating on. We can't do any worse than that. That's the minimum amount of balloons that we can pop. And now we're going to solve the rest. We are going to check how many other balloons, other than the first one, the one that we are iterating on, we can pop. Since we have sorted them by the end coordinate of their interval, now we can just check if their start position is less than the end of the current balloon. And if it's so, then we know that we can pop this balloon with the same arrow that would pop the current balloon. So first of all, we check that the current balloon plus the popped balloons is still in the bounds of the balloons array. And then we check if the start of the next balloon is less or equal than the end of the current balloon. And if it is so, then we know that we can pop this next balloon with the same arrow that is going to pop the current balloon. So this is a quite neat trick to get the next balloon, because if this is the current balloon and we haven't popped any other balloon yet, so we've only popped one balloon, which is the current balloon, then this would be current balloon plus 1. And as soon as we pop another one, this would be plus 2, and so on, and plus 3. So we would iterate until we find one balloon that cannot be popped with the same arrow that is popping the current balloon. So yeah, if we find one, and so until we find one that is not possible to pop with the same arrow, we increment the amount of balloons that we've popped so far. And that's going to be helpful here, where we want to skip all of those balloons that we've popped with the same arrow. We don't want to iterate on those again, because we already popped them. So I'm going to submit the solution so that you can see that it works, and this is optimal. It is a runtime complexity of O of n log n, where n is the amount of balloons, and a space complexity of O of 1. We aren't storing anything crazy, no data structures. So that's it for now, and bye.